the test day is going to be. So before we start today's stuff, let's go over the quiz, whether you did it or not. If you want to pull up your quiz on Schoology, it'll tell you the correct answers now. All you got to do is pull it up. It'll tell you your answers that you selected, as well as the correct answers. It shouldn't take too long to do this because there was only like 6 slides or 6 parts of this. So let's quickly go over the answers so that you're prepared for the test next week. If you want to pull up your quiz, go ahead and pull it up so you can see how you did. I'll be putting these in the student portal shortly, but the grade's already in there in Schoology for you. If this loads, it's a little slow today when I'm especially... What? Come on.
It's supposed to just tell you your grade out of 100, right?
Yeah, it's out of 100. Usually you fail the class?
Usually I am failing this class, but right now this is one of the classes I'm not failing.
That's good. Come on, screen.
Pay attention, Claudia. Get off your phone. Pay attention. I know. I'm going to get out of here.
Okay. Your question order might have been a little bit different, so just look for this question real quick if you need to, if you got it pulled up. First question was talking about ice cream truck guy. Saw an ice cream, recorded the temperature it was outside, and how much sells an ice cream. You didn't really have to do much other than just analyze it because I created the scatter plot for you, and I created the regression equations. There's a linear regression equation here, and there is a exponential regression equation right here. You had to look at the scatter plot to determine which is the best regression equation for the data. The best one for this data is linear. It's pretty straightforward. It doesn't exhibit any type of curve in the graph. So this is more linear than it is exponential. Question part 2 of this question, if you wanted to predict the temperature on a day ice cream sales total $215, what would you do? Take a look at the table and at the graph. Temperature is X. You can see it here. You can see it on the X-axis. Ice cream sales is Y. You can see it there. It's on the Y-axis. Okay. Because of those, if you want to predict temperature, you're looking for X. The ice cream sales is Y, so you're going to plug in 215 for Y and solve for X. And we got to be conscious of which variables we are picking. We're plugging these in for the right variables, and that's one of the things that I think you guys mess up on the most. Okay, don't always assume you're plugging in for X. That's not always the case. Okay. The prediction I made above is an example of. This is an example of interpolation. Why is this interpolation? Well, look at 215. The lowest Y value was 120, and the highest Y value was 230. So 215 is within the lowest and the highest. That means it's an interpolation prediction. If it was not within the lowest and the highest values, then that would be extrapolation. Okay. So interpolation is within our range of data. Extrapolation not within our range of data. Next question. Move this out of the way. This question right here says, interpret the information. Some of you gave me what the correlation was. You said it was fairly strong, positive, linear. That's not the interpretation of the graph. The interpretation of the graph is, what are you learning from the graph? This particular graph, for the most part, as you get older, your blood pressure goes up. That's what it's telling you. Okay. Now, I got a couple answers that says, as your blood pressure goes up, you get older. That you got points taken off for that because that's not necessarily the case. Remember that X always explains Y. Y depends on X, not the other way around. So you don't want to say, hey, as blood pressure goes up, you get older. is that's not the cause. The cause of your blood pressure is based on your age. Okay. Next question. This is the matching part. I'm not going to go over this because you can pull up the answers. I'm just going to go over strategy real quick. I would start out with the strongest graph. Which one of these is the strongest graphs?
0.992.
Okay, so 0.992 is the strongest R value, which is a positive correlation. So which one of these is the strongest positive correlation? The middle one right here. Okay, so that's where I would have started and would have gone from there. Okay, then work your way to the negative graphs, the ones that have a negative correlation, and look at the ones that have the strongest negative correlation and go from there. That's the approach I would have made on something like that. But you can see the answers on Schoology. Describe this correlation, strength, direction, and form. So this is a question where you do describe the correlation. Please give me more than 3 words. Stop just saying strong, linear, positive. Okay? Give me a sentence. This is a mostly strong or fairly strong negative linear correlation. Should have all 3 of those things to get full credit. Okay? Fairly strong negative linear correlation. Which of the following just correctly describes the correlation above? You see this curve coming down. This is more exponential than it is linear, but it's a negative exponential, and it's pretty strong. So it's a fairly strong negative exponential correlation. It's pretty strong because, hey, it's still you can see a pretty distinct pattern. The dots are pretty close together. That's pretty strong. Last question. I got some funny answers here because look at the first sentence. Some of you are just not even reading the answers. It says the data in the scatter plot above is neither linear nor exponential. Right. Would you consider it to be strong, weak, or no correlation? And you want to know what some people said? It's a pretty strong exponential. Or it's a pretty strong linear. Like it literally says it's neither one of those. Okay, it is neither one of those. It's another function that we're not going to talk about. The whole point is, can you determine whether it's strong or weak? And it is very strong because you can see that all the dots are close together and it follows a pattern. Okay, so you had to say that it was strong, and you had to tell me because either the dots are bunched together or it shows a pattern, one of those things. Okay, it's not strong because it's positive. It's not strong because you think it's linear. That's not the reason why it's strong. Strong because it follows a pattern. The dots are really close together. Any questions on your quiz?
Pass.
Good. All right, so here's what we're going to do today. I have a new concept for you. This is the second to last thing that we're going to do before the test. Really have cut this lesson down from what it used to be because obviously we're a little different. We can't do all the things that we used to do before the pandemic hit. If you guys are at home, please take a moment to print out 7.5 homework real quick. It'll be a lot easier for you if you print it out. Obviously, if you don't have a printer, you will need to draw these graphs, the stuff that we're going to do on your journal. But if you have a printer, take about a minute. I'll hang tight for just a second for you guys to print this out. It looks like this. It has a Ferris wheel on the front. Go ahead and print that out. And actually, while you guys are trying to print that out, I can start this out because I have a little video I want to show you. So let me go to this here. And you can see the name of it right there, periodic correlations. I'm going to start this out with a Ferris wheel. Have you guys ever been on a really, really big Ferris wheel? Now, I'm not talking about the one that's next to pinballs, that little rinky-dink Ferris wheel. I'm talking about one that is super, super high.
Not really.
No? You ever heard of the Singapore Flyer? Singapore Flyer is one of the world's tallest Ferris wheels. It's really, really cool. It's got an overall height of 165 meters to the very, very top. It actually starts out at 15 meters. There's a platform you get on at about 15 meters above the ground, and it takes you up to all the way to 165 meters above the ground. There are 28 different capsules to go into, and they're completely enclosed and air conditioned. The capsules on the inside literally rotate with you because those capsules are fixated to the outside of the wheel. So it rotates in the inside so you're always level with the ground. That's pretty cool. It only rotates at about 26 centimeters per second, so it's slow enough for you to get on and off without even having to stop. Okay, it takes about 30 minutes to get all the way around. Let me see if I can optimize this real quick to play the video, and hopefully you guys at home can see this too.
Today I'm taking flight on one of Asia's most iconic architectural and engineering marvels, the Singapore Flyer. All right, here we go. Hello, Singapore. My first sight is the gardens by the bay with the conservatories and the super trees. The capsules are really spacious. There's actually 28 of them on the wheel. Each one holds 28 people, and it takes, you guessed it, 28 minutes to go all the way around. Wow. I have a 360-degree view of the city, and in the distance, I can see Indonesia. The Singapore Flyer is the tallest observation wheel in the world, 30 meters higher than the famed London Eye. So we're just arriving at the top, and they say when you get to this point of the journey, you're supposed to make a wish. Oh, that was fantastic. What a relaxing and unique way to see the beauty of Singapore.
All right, so obviously, what we're going to do is we're going to model your guys' distance versus the time that you're on the Ferris wheel, the Singapore Flyer here in particular. So again, if you have not printed this out at home, print this out. If you don't have a printer, you guys will have to. I'm going to actually take this optimize. You guys will have to draw this graph. You don't necessarily need to draw every hash mark, but you will need to draw this on your own paper in some certain way. So if you have this time printed out, here's what I want you guys to do once you have it printed out. All of you guys here in class have it in front of you. Take a look at question number 1. It gives you some of the information about the Ferris wheel at the top. I've already talked about the information. If you look at the table shows you the time in minutes that you're on the Ferris wheel and how high you are off the ground. Now, the Ferris wheel in this particular situation is going to go around twice. So you're going to take about 60 minutes, about an hour for you to go all the way around the Ferris wheel twice. What do you notice about the height off of the ground and the Y values in that table? So you're going up, and then at a certain point, what happens to your height? You start coming back down. And then when you go up again, you go back up again, and you start coming back down again. Okay? This is what I want everybody to do. You're going to actually plot these points. Okay, there's about 20 of them. Plot these points on your scatter plot there. Okay? So for example, don't take long to do this, guys. We can move on. For example, the point 015, that means that's the point you get onto the Ferris wheel. Remember I said there's a 15-meter platform where you load and unload the Ferris wheel. So your first point, your first dot on the scatter plot will be about right there because it's 0 time and 15 meters high. Your second plot on the scatter plot, you guys, this is all on your paper. You don't need to be on your computer right now. All on your paper. Second dot on the scatter plot will be at 2 and 21.5. So plot that point. It's about right there. And keep going. Okay. This should not take you any longer than 5 minutes. I want you guys to spend 5 minutes to do this. Ruby, what are you doing? Don't put it in the Desmos yet. Did you put it on your paper already? Okay. If you guys at home have any questions, let me know. I'll keep going up with you guys. You can check the screen to see if you are doing it right. I'm going to start putting out some of the rest of these dots. Just plotting. I think you guys know how to make a scatter plot. After 15 minutes, it's about halfway through. That's at the highest point, that 165 meters off the ground. That was what we talked about being the highest point. Then you're going to start to come back down. And it's going to look something like this. Michael, did you finish your scatter plot? And this is what your scatter plot should have looked like. Does it look like that?
Yep.
If you haven't finished yet, keep going. Give you about another minute or so. Do you guys, anybody at home need more time to finish their scatter plot? All right. So here's what I'm going to, obviously, taking a look at this scatter plot, it's not linear, it's not exponential, it's not logistic. This is something a little bit different. And unless you guys have taken pre-cal prior to taking this class, which maybe one or two of you, you probably haven't seen a graph that looks like this. But it's pretty common. We call these periodic functions. A periodic function is something that repeats its values in regular intervals. It looks like a wave. Why do you think our graph looked like a wave? Well, Claudia a second ago said, hey, are we going to go up? Are we going to reach our highest point on the Ferris wheel? And then we're going to come back down. And then we're going to get to the lowest point of the Ferris wheel, which is that platform. And then we're going to go back up again. And then we're going to come back down. And if you stayed on it forever and ever, that would just resemble that wave going over and over again. Now, there's a couple of things on here that are not going to need any explanation whatsoever because you should know some of these terms, such as the maximum part of the graph. The maximum is just the highest point, right? I don't need to explain that to you guys. What do you call the lowest point? The minimum. Okay, there's the minimum. We also have a name for this line that goes through the graph. This line cuts through it halfway through. Remember back from geometry, when you cut something in half, exactly, mirror image, what is that called? The axis of symmetry. Yeah, the axis of symmetry. It's not quite exactly axis of symmetry because it doesn't mirror, but that's what it is. It's cutting it halfway through. It's like a midpoint line, all right? The axis of symmetry. There's a couple of it. There's two new terms. I don't need to explain those, but there's two new terms here for you guys. One is the period. The period is a distance from one maximum to another maximum or one minimum to the other minimum. Okay, that's called a period. The other new vocabulary word is called the amplitude. The amplitude is just the distance between the maximum and the axis of symmetry or the minimum and the axis of symmetry. You guys don't need to write this down because if you look at page 2, it's already given to you guys. All right. So we'll go over that here. We'll copy some of those notes here in just a second. But you don't need to write those down, Aiden. It's already up. I already printed it for you on page 2. Oh. Wait. Yeah, it is. Look at the page 2 on the bottom.
What?
Oh, on the bottom.
Oh.
Oh. Well, let me get there. Okay. So this is what I want you guys to do for number 2. Number 2 asks you guys to do a couple different things. First, before you even do anything, here's what I would do first. Make a nice, smooth curve through your scatter plot all the way through, connecting all your dots. Do this real quick. Nice, smooth curve. I know. I'm writing it on a freaking computer. Come on, guys. Throw me a freaking bone here. All right. Question number 2 is asking you to sketch a dotted line to represent the axis of symmetry and label it. When I did this earlier, I forgot to make it dotted, but it doesn't really matter. Eyeball it and see if you can figure out where the axis of symmetry is. Okay. Write that on question number 1. Draw it in. And then I'm going to put mine up and see it. Let's see how close you are. Okay, eyeball it. Look about where halfway through the axis of symmetry is going to be at. Yeah, the little line. And put it in. Don't worry about being right or wrong. There's no point of being right or wrong right now. That's not the point of this. Eyeball it. Tell me where you think the axis of symmetry is at. Here's where I drew mine. Should have been dotted, but oh well. Here's the other thing that I asked you to do. Label the period and amplitude on the curve. Okay? So let's label the period. There's a couple of different places you can label the period at. Here's where I labeled the period on my graph. You can label it there on your graph. Where else could I label the period at? At the top. Like this is also the period. It's the same exact distance. Okay? That's also the period. You don't need to put both. You just need to put one or the other. Okay? This is also the period right here if you really wanted to show the different time where the period shows up. Okay? You don't need all of them. You just need one of them. But that's the period. Maximum, maximum, minimum, and minimum. What about the amplitude? How would I label that? Yeah, it doesn't matter where you go. It could be right there. There's where I put it on the slide. It could be right here as well, right? The minimum to the axis of symmetry. That could also be the amplitude. It could be right here. You don't need all of those. You just need one of them. Label it. Okay? Now I'll do this for number 2. For the rest of number 2, where it says period and where it says amplitude. It says estimate the period and the amplitude below. So tell me about what is the period? What is the number for the period? Tell me about what is the number for the amplitude. Try to guess about what it is. Count it out, subtract if you need to. Figure out what you think the period is and what do you think the amplitude is. So the period goes, how far over do you think the period starts? Where does it start at? It starts at 0. And where is it ending again before it starts to go back up again?
28 or 30.
About 30. Okay, so what do you think the period is? 30. All right, put that down. Do the same thing for the amplitude. Figure out about how high it goes and where is this axis of symmetry at? Subtract that. Okay. Put your estimate for the amplitude. Don't worry about being right or wrong. Just put an estimate in there. Whoops. So this is where we're at right now. We're on question number 2. So you said 30 for period. What did you guys estimate for the amplitude?
60.
About what did you say, Nick?
I said 60, but that's just because I did 100 and looked at the differences between
Okay.
them.
That's a good guess. You said what? About 95? About 75? Okay. 65? All right. You guys, don't worry about the fact that y'all are all different. Write it down what you think it is. That's fine. And let's go to the next question. Because the next question, I think we're all in agreement on. What do you think the period represents in the context of the problem? What did you think the period was? 30. You guys are exactly right on the period. What do you think that is in the context of the problem? What does that 30 represent? The 30 minutes that it takes to go all the way around the Ferris wheel. That's exactly what that is. Yeah. So there's your answer for number 3. It takes 30 minutes to go all the way around. Yep. It's about 30 minutes, 28 to 30 minutes, depending on how fast they have it running. But 30 minutes is almost exactly, and that's what the context of the problem was. And you guys were all right on the dot with that. Now you're a little bit more off on the amplitude part from each other, so we'll talk about that in just a minute. But in order to get there, we are going to need to put this data into the calculator. I'm going to teach you about the last equation you guys are going to do for the unit. You've done linear, you've done exponential, and you've done logistic. Now we're going to do what's called a sine function or a sinusoidal function. What's up? Well, you all had different numbers. What did you say? Yeah, leave that there. We'll come back to that in a second. Okay. So open up this Desmos calculator. Whoops, I wish I would have opened up in a new. You will need to type in your data into the calculator. So the data I'm talking about is the. Whoops, why did that not open? The data is the stuff from this first page of the screen of the document. You should have already a lot of practice typing in these numbers into the calculator. Once you type it in, I will go back to showing you how to write this equation. We'll do it together, but it's going to show you it's going to type in the scatter plot that you just drew, plus it'll give you the equation for a sine function, okay, a sinusoidal function. I'll do it with you guys, but go ahead and start putting in the data into your Desmos calculator. I'll do it with you as soon as it loads up. There you go. You can do it on your phone, you can do it on your computer. Make sure that you guys zoom in so that you can see all of it, everything that you plotted. Press the little button there to zoom in. All right, this is what mine looks like after I've zoomed in. Plus, I have the sinusoidal equation already logged in there for you guys. If you use that Desmos calculator from the computer or the assignment or the slides, it's already got the one in there for you. Okay. Anybody have any problems putting this stuff in? You guys should be used to this by now, right?
Yeah.
Okay. I'm going to help you guys write this equation down. All right. So have this screen up, especially for you guys here, so that I can go back to the other screen and help you guys write it down. It's got 4 different variables this time, A, B, C, and D. And we're going to talk about all of them here in a second. But 4 different variables that we have to plug in. And you notice how it has the SIN. That stands for sine. You should remember that from geometry. Okay. So let me go down to that question. It doesn't look like that. What does it look like?
You supposed to put a list, right?
Yeah.
It looks like this.
Yeah. I just zoomed mine out a little differently. Did you zoom yours? So it looks like your scatter plot on your paper? Then you're fine.
Oh, okay. I was going for that.
Yeah. Okay. Why don't you guys, somebody here in class that's in person, help me read out what these letters are so I don't have to clicking back and forth. Okay. So y equals. What is the a value? And it says round to the nearest hundred, so that's 2 decimal places. What is the a value? 75.02. Sine. If you want to put the multiplication dot, you can. You don't need to. Okay. Sine. Open bracket first. So there's a big bracket because there's double parentheses. You can do double parentheses or you can do 1 bracket and 1 parentheses. It's up to you. Okay. What is the b value? 0.21. Okay. And then I'm going to open parentheses again. So there's a double parenthesis. I know it's kind of confusing that way. This is the way it's written. It's x minus the c value. So what's c? 7.50. I'm going to close my parenthesis and I'm going to close my bracket. Last part is plus d. So what is the d value? 3.01. Again, the best part is that you don't have to memorize this. You don't have to memorize it because it tells you how to write it in the Desmos calculator. Whoops. It tells you how to write it right there. I just used bracket instead of the double parentheses. That's the only difference. You guys all see that, right? It tells you how to write it right there. So this is the equation for my sine function that models the going up and down on the Ferris wheel on the height off the ground. Take a look now at your answers to number 2. Look at the a value. What do you think the a value represents? Somebody hit it in this class right on the head. 75. Daniela hit it on the head. The a value is always the amplitude. So write that down for number 5. Because some of you were a little off. And Nick, you were close.
75.
Yeah. The a value is in the equation is 75. It's right there. So 75.02 is the A value. What do you think that represents? It always represents the amplitude. Write that down. It always represents the amplitude. So look at number 6. What is the D value? D value is right here. 90.01. Where do you see that value in the model of the single port flyer? What was 90 representing?
The middle.
The middle, okay? Not just the middle, that's the center of the wheel. That's how high it is off the ground. It was literally the center of the wheel of the circle. It's turning 90 feet. That was that axis of symmetry too. If you, depending on how good you eyeballed that axis of symmetry. Write down right there about the axis of symmetry. So write that in there too. I'm not writing it here, but you guys write that in there too. And 90 was the center of the wheel. It's how high the center was off the ground. Number 5 was the A value in the equation was 75.02. And what do you think the A value represents in this equation? It's always the amplitude. A is always the amplitude. So let's go back to our Desmos calculator. And I can show you how to do it on my screen if you just watch me. It says use a Desmos calculator to determine the minimum and maximum Y value by hovering your mouse over the lowest and highest points. So watch this. If I double click, it usually works here. Everything is just, this thing is running super slow. Does it work on your computer? Look at that. If I double click up there, the highest point, I just had it up. You see that? What's the Y value of the highest point? Which one of those is the Y value, the 15 or the 165? Okay, the 165 is the Y value. So that's the highest value. If I go down here to the bottom and click on the lowest point, it's 15, right? So there you have it right there. You have your highest and your lowest. It's taking a second to pop up on the screen. You have your highest and your lowest Y values. The lowest Y value is 15. Still not popped up. There it is. The lowest value is 15. The highest value is 165. So write that down in for your number 7. Minimum Y value is 15. Maximum Y value is 165. Now answer question 8 and 9. And we'll come back to those answers in just a second. And then we'll break for lunch. Answer 8 and 9 real quick.
Accidentally refreshed the good ones.
You don't need it. You already, if you wrote your equation down, you should already have it. Add the minimum and maximum together. So you added the minimum and maximum together. What did you get? 165 plus 15. You get 180. And divide that by 2. You get 90.
Is the B value 0.1?
The B value is what? 0.21?
No, is that the value?
No, not 90. 90 is 90 is the D value.
No, the B.
What about the B value?
What is it?
That's the next question.
Oh.
So let's answer this question first. Okay. You should have done that. That should have been pretty straightforward. Okay. What does this tell you about the D value? The D value is always that axis of symmetry. It's halfway in between the maximum and the minimum. That's why if you take the maximum and the minimum and divide by 2, you get exactly what the D value is. It was almost exact, right? So always halfway in between the maximum and minimum, that axis of symmetry. Make sure you add that in there. This should not be the only thing that you write in that question. All right. Good so far? Did you answer the next question? Take 2 pi and divide it by the B value. So you'll need the pi button on your calculator. So multiply pi times 2 and divide it by the B value in that equation. The B value was 0.21. When you did that, what did you get? Who did that already? You guys had it. 29.91. Good. Where do you see this number in the context of the problem? This was really, really close to what? What value do you think that is?
30.
Close to 30, which is the period. Yeah. So if you have the equation and you take 2 pi divided by b, you can always find the period. Always. That's going to always be the period. Okay. So let me help you fill in these notes so that you have them right there on your paper, and you don't have to worry about going back and looking at notes through the slides or anything like that. I have these already written up for you. Let me go back here. So let's fill in these notes so that you have them right there on your paper. You ready? First is, this is how you write the standard form of a sine function. If you don't have to memorize it because the Desmos calculator gives it to you. But this is how I write it with the brackets instead of double parentheses. It's just a little bit easier to read. So remember, this is just times. You can write it or you don't have to write it at all. But I'm just showing that in there. I wanted to write that there because I didn't want it to look like ASIN, so it's a little bit, they just separated a little bit. That's just a multiplication symbol. If I just have the equation, how do I find the amplitude? Do I have to do any math? What is it? It's just A. So put it right there. Just remember that A is amplitude. Easy to remember. If I have the equation and I want to find the period, what do I do? What did we just do a second ago? You take 2 pi and you divide it by B. So that's how you find the period. You with me, Lupe? If I just have the equation and I want to find the axis of symmetry, what do? Do I have to do any math? What do I look at? Which letter is the axis of symmetry?
No.
I know which letter is that line.
Oh.
Not C.
No.
D. It's just D. Did you say that, Claudia? If I just have the equation and I want to find the minimum, take a look at this. The minimum is down here, and this is the axis of symmetry. Well, this is D, and the amplitude is always A. So how do I figure out what the minimum is if I know what D and A are? Not add them, subtract them if I want to find the minimum. So D minus A gives me the minimum value always. If I have the equation, I just take D and I subtract A, I'm always going to have the minimum value of that function. How do I find the maximum value? Say it out loud. Just D plus A. You're going to add them together. It gives you if I add the amplitude to the axis of symmetry, it's going to give me that maximum value. Now the last two, I don't really care about too much. I'll show you what it looks like and how it works. But the C value does have a meaning. C value is always the horizontal shift. It shifts the graph left and right, and the D value is technically the vertical shift. It moves the graph up and down. Okay. Just to kind of show you what that looks like or what that means. If this loads, well, everything is slow. Come on. Should have had it all already up. Come on. Golly, this stupid computer. There it goes. Well, still. Come on. Oh my God. Oh, bear with me, guys. We should open this one up too. Get it started loading already. Just waiting on this stupid thing to load. Why is everything running so slow?
Why'd you break it?
It's because I'm recording. It's taking forever. Well, it's not loading right because it's not.
Just stop recording and then start.
Oh, there it goes. There it goes. All right. So here are the sliders I wanted to show you. What does A stand for again? The amplitude. If I slide, you can see. Well, by changing the amplitude bigger and smaller. God dang it.
You got this, dude.
Who was that? Pedro?
Nick. There you go. Making the amplitude bigger and smaller, I change the maximum minimum. Okay, the biggest there. Let's see if it actually works.
What are you sliding?
It's changing the A value, and this is just example. It's a little slider. Yeah, well, it's hard to see on y'all's screen there, but it's like it's a slide here. B changes the period, so I can if I go longer periods, I flatten out the curve. Flatten the curve. Isn't that what we want to do with coronavirus? All right. Okay. We just got back from lunch. Hang on. No, not yet. C shifts my graph left and right. So let's see if it works. There it goes. You guys can play with the sliders if you open up the PowerPoint. Okay. D moves the graph up and down. So I can move it down if I go to the left. I can move it up if I go to the right. This stupid slider. All right. All right. Here's the last thing. Here's what we didn't get to do in class. Normally, we would break up into groups. I'd assign you guys a different city, and we would do this together. But I'm just going to show you what this looks like. Hopefully, it all works with this screen here. But have you guys ever noticed that the days are shorter in the winter and longer in the summer? Okay, you guys should know that by now. We have long days in the summer. We have short days in the winter. But it's not. Is that the same everywhere around the world? What changes?
Daylight savings.
Well, no. I'm talking about how does the amount of daylight that you have in a certain city change depending on where you're at?
Because it's how the sun hits the earth. Like if you go up in Alaska in the summer, they have real warm days, but in the winter they only have.
Have you been to Alaska?
No, but I know.
Yeah. If you've ever even just been to the northern United States, when I went to Seattle and Vancouver a couple years ago, I flew into Seattle, got there late. It was already dark. Checked into the Airbnb, went to bed, got up the next morning. The sunlight was coming in through the window, hit me in the face, and I was like, okay, it must be like 8 o'clock or so. I looked at my watch, and it was 5 a.m. Like 5 a.m. sun was already coming up. This is in the middle of summer. Okay, and then when at night, it didn't even get dark till like 10 p.m. Like they have really, really long days in the summer, much longer than us. But on the flip side of that, they have really, really short days in the winter. So like if you go there, I've never been there in the winter, but if you go in the winter, sun doesn't come up till like after 9 a.m., like 8 to 9 a.m. And it sets at like 5 p.m., 5 or 6 p.m. What?
Don't people have to live super high up or super low, have to sit in front of lamps?
Yeah, I mean, if you go to, like Michael said, Alaska, if you go all the way to Alaska or those farther ones, you have some times where you have like literally like 20 hours of sunlight and only 4 hours of darkness, and vice versa in the winter. So we used to do this activity in class where I assigned you guys a city. I have 6 different cities, 3 in the northern hemisphere, 3 in the southern hemisphere. Houston, Philadelphia, and Winnipeg are all in the northern hemisphere. You probably know where those are. Winnipeg's in Canada. And then you have Porto Alegre, Valdivia, and Stanley in the southern hemisphere. Porto Alegre is about the same distance from the equator as Houston is, but just on the other side of the hemisphere. Same thing with Valdivia and Philadelphia, and Stanley and Winnipeg. You also should know that I already created these graphs for you, and let's see if it actually pops up. We used to plot these together, put them on little transparency sheets, and we see how they look together. But I'm going to just show you with the Desmos, and let's just see if this works. So the first thing I did was I plotted the days throughout the year. You can see the first day is January 1st, and then it goes all the way to the 335th day. That's sometime in December. And how many minutes of daylight there are in that particular day. In the winter, it starts out really, really short amount of daylight. In the summer, you have a lot of daylight, and then coming back down to the winter, you have less daylight again. So I'm going to pop on that scatter plot, and hopefully it pops up here. I hate you. There it goes. So there's Houston. If I put in the equation for Houston, don't worry about writing it or anything like that. Here's the equation as it pops on. Again, right here in the hello. Yeah, I put it up there at the front. Yeah, just the big one. Oh, yeah, the bigger one in the stake. That's it. Yeah. Summertime. Where's the summertime in relationship to this graph? Yeah, in the middle, in the top. Those are the longer days. Okay. We go farther from the equator. We go to Philadelphia. What happened? What do you think is going to happen with Philadelphia?
It's going to be more of a day. More of a day.
Well, the summertime is going to be longer, but what's going to happen in the winter? Shorter. And if I can get these things to freaking pop up. God. What?
I think that's a sign to say that we're done for today.
Well, we're almost done. I just wanted to show you guys this. Well, I'm gonna stop this recording and just see what happens. Everything's. Let me just get you started on this, and you guys can finish this up on your own. This practice page has 3 different data sets. It tells you the highest daily temperature averaged out over each month for 3 different cities. But you can't, and you can just use the same calculator that you used for the last example, but you can't put January, February, March, April, May into the Desmos calculator. So what do you guys got to use instead? Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9. What happens when you come back to January?
Starts back at 0.
No.
1.
At 1, 2, 3. So you're gonna have to make sure that you do that for each one of those. You're gonna put it in 3 times, and you're gonna write 3 different equations for them, just like we just did, and then answer the questions at the bottom. It shouldn't take you longer than about 20 minutes to finish this assignment. Okay. Don't forget that you guys there's no Zoom on Wednesday. You're gonna finish this in class, turn it in, and then it will be a short ed puzzle for you to watch, and that's it. I won't be here on Wednesday.
Do we have to come?
Okay. No, you don't have to if you want to do it at home. Okay.
No, wait, so you're saying Wednesday there's just going to be an ed puzzle?
Yeah, Wednesday, just finish this, and there will be a new ed puzzle to watch. It'll be like 20 minutes or less.
Oh, okay.
Okay.
Where are you going to be?
We have our JV district tournament.